Hi, welcome to BC Video 10.4 Part 2, and this is rectangular and polar coordinates on the TI. That's going back and forth between rectangular and polar coordinates, and also rectangular to polar equations. We'll do polar to rectangular equations in another video.
Okay, so looking at numbers 7 through 10, they're giving you r and theta, they want x and y, so now we're talking on the calculator. Basically, you'll be able to go to the catalog and just press the letter P and scroll down until you see a P with an arrow pointing to an Rx and a P with an arrow pointing to an Ry. So this is polar to rectangular x, polar to rectangular y. So what you'll do is you'll select that key and you'll simply enter your polar point. And when you do that, what you'll get is you'll get the x-coordinate equivalent to that. And if you do P, R, Y, you'll get the y equivalent. It turns out 2.59, 1.5. Now you can go in the opposite direction. Again, on your calculator, just use catalog, press the R, and scroll down. And it'll look like this: rectangular to polar theta, rectangular to polar radius. They don't have it so you can get both coordinates, theta and r, at the same time. You have to do them separately. So here's an example. Okay, if I do, and notice I've entered the same thing for both of these. One I'm in exact mode, not a very pretty answer. One I'm in approximate mode, much better. And same thing with getting the r. And remember, these are angles, so this would be in radians, assuming you're in radian mode in your calculator. And this is giving you your r, which will be a number, a length of the radius, and that's an exact mode, and that's an approximate mode. Okay? Okay, and here's the other direction: polar going to rectangular x, polar going to rectangular y. So the coordinates of the point would be 2.703, 1.302. Okay, so once again, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared. If you forget any of this, you can always recreate it by drawing this picture, and the reference angle for theta is the inverse tan. So 27 through 36, convert the rectangular equation to polar form. So now we're not going from coordinates to coordinates, we're going from an actual equation to an equation. But basically the rules are more or less the same. So these are all, as you can see, in x and y. They're all rectangular equations, and they're asking you to change them to polar. So the things that we know, and you should know that x squared plus y squared is r squared. We already know that x is r cos theta. So if I factor out the r, I get the following. And then since that product is zero, either r is 0 or r equals 2a cosine theta. Now r equals 0 means it's the pole, because when you have no radius, no matter how many times you spin around in one place, you haven't moved anywhere, you're still at the pole. Now, as far as r equals 2a cos theta, we will get to the point where you'll need to know that this equation gives this graph. But for now, you can use the rectangular equation. You should know it's a circle because it's x squared plus y squared. And what you'll do is you'll bring this negative 2ax over here. You'll put the x's, leave a space, put the y's, leave a space. Then you'll complete the square, if you remember. So you'll take half of 2a is 1a, squared is plus a squared, so I got to add that to the right. Half of 0 is 0, 0 squared is 0. So I factor it, I get x minus a all squared plus y minus 0 all squared. That's a circle, center a, 0, radius a. Now, it's a lot easier, actually, if you recognize it as being the equation of a circle, because you're looking at the radius right here. So let's say 2a is 10, the radius is 5. If 2a is 40, the radius is 20. And the okay, so if there's a number there, that's what you have. Now, as far as one thing you'll notice is that the coordinate, or should I say the intercept, if we look at it in xy, the x-intercept will end up being at half of whatever this 2a is. So the x-intercept will be a comma 0, the radius will be a, which makes it be a circle tangent to the y-axis and symmetric with respect to the x-axis. And we will learn later on that cosine will always have that effect to be symmetric with respect to the horizontal axis. X equals 10, which of course you know in rectangular is a vertical line. Looks a little uglier in rectangular, so now we're moving to again, still changing rectangular equations to polar. So what is x? X is r cos theta. Divide both sides by cos theta. Rewrite 1 over cos theta as secant theta. So what can look very simple in rectangular can look quite ugly in polar, and vice versa, which is why polars exist. There are some, like the roses, you would never want to deal with them in rectangular form. Okay, now it's hard to believe that this is going to give a vertical line, so I just want to kind of convince you of that fact. I'm going to let theta be 0, pi over 3, pi over 2, and negative pi over 4. The secant of 0, of course, is 1, so 10 times 1 is 10. The secant of 60 degrees is 1 over the cosine of 60 degrees, which is 1 over the sine of 30 degrees, which is 2. 2 times 10 is 20. The secant of pi over 2 does not exist. There's a vertical asymptote there. And the secant of negative pi over 4, you could figure it out, will be 10 root 2. So what happens when I graph these points, it's really kind of interesting, but they all end up on the same vertical line. So you have your 10, 0, which I found here, and my 20, comma, pi over 3, which is 60 degrees, so that's a second point. At pi over 2, there's nothing, so forget that. But we do have a point 10 root 2, comma, negative pi over 4, and they will actually all line up on that vertical line, which is kind of